So for part B, determine how many balls must be bowled to provide more than an 80% chance of taking at least 3 wickets. I did just change the wording slightly there to make it more appropriate with what I'm dealing with, but same sort of idea. So this time we're looking for taking at least 3 wickets. So we're looking for the probability of x being greater than or equal to 3, and we want that to be at least an 80% chance. So we want that to be greater than 0.8. So same idea as last time. We're looking here at probability of x equaling 3 plus probability of x equaling 4 plus and on and on. So I don't really want to do all of that work. What I'm going to do is I'm going to say that, well, I could sort of take the other side of this part here and say that, in this case, sorry, the probability of x equaling 0 plus the probability of x equaling 1 plus the probability of x equaling 2, so that's the other side of this, we want that to be less than 0.2. Now this one isn't going to be quite as nice, so this time we've got x equaling 0 or 1 or 2, oops, that is a 2. We've also got p equals 0.04 like last time, and we've got q equals 0.96 like last time. So just a little bit more working out. That gives now ncx, so it's going to be nc0 multiplied by 0.04 to the power of 0 multiplied by 0.96 to the power of n. That's for the probability of x equaling 0. For the probability of x equaling 1, it's going to be nc1 multiplied by, what am I doing, 0.04 to the power of 1 multiplied by 0.96 to the power of n minus 1. And then when x is equal to 2, I'm going to have nc2 multiplied by 0.04 to the power of 2 multiplied by 0.96 to the power of n minus 2. And I want all of that to be less than 0.2. Now we can simplify this a little bit. So that there becomes 1, that there becomes 1. So we've got 0.96 to the n plus, now nc1, well that's just n, and that's multiplied by 0.04, which is multiplied by 0.96 to the n minus 1. And then we're adding on, now this is not going to be nice, so I might actually just leave that part as it is. nc2 multiplied by 0.04 to the power of 2 multiplied by 0.96 to the n minus 2. And we want that to be less than 0.2. Okay, so I'll just pause the video. So I was trying to solve this problem using my calculator and found that it didn't work to just type it into the main screen and highlight it and go solve. This calculator can't handle it. However, if you have the TI Nspire, then that will do the trick for you. The way we have to do this is we have to do it using the graphs and tables screen. So what we do is we go into the graphs and tables. We're going to tick the box here as soon as we type in something, but it's going to be binomial CDF, and going to have, now our minimum value is 3. We don't know what the maximum value is, that's what we're trying to find out, and we don't know the number of trials, but we know that the probability of him getting the wickets is 0.04. So I've written that in, just going to tick that and click this table button here. And there it is. Now I fixed the table up beforehand, but you do that by going to the XY here and you just set the starting value at something reasonable. I picked 100. And what I'm going to do is I'm going to scroll down until I find where it ticks over 0.8 as the probability of him getting the wickets, and there it is right there. So this is where it's first ticked over, which means that it takes 106 deliveries to ensure an 80% chance of getting the 3 wickets. So leave that there. See you guys.